Hi, I'm Rich with insideHPC. We're here at SC13 in Denver, and we're here at the Emerging Technologies booth. And I'm here with Roger from System Fabric Works. Roger, how's it going?
It's going great. We're enjoying ourselves. We brought everything that we could bring in the back of a minivan, and we're demoing away here.
Okay, so what are we showing here? What do we got?
So we basically got two things here at Supercomputing 13. In the top of the rack, we've got microservers. We've got three Freescale 4240s, and those are what I call the jumbo shrimp of microservers. They're not really micro, they're fairly good size. In fact, they produce about as much computing power as a Intel Sandy Bridge processor. So for a microserver point of view, that's quite a bit of computing power. On the bottom of the rack, we've got a mini Lustre scenario, if you will. We've got about as small a Lustre package as you can put together in one place. And that's basically to serve our Freescale array here so we can do data and show how the microservers can be used in high performance computing environment.
So what do we got here on this side of the station?
We've got a version of the Intel Enterprise Edition Lustre running. This is actually wireless, which is pretty handy here. We found that we're actually able to run the Lustre system overnight, take this back to the hotel and watch the system overnight, make sure it was running and ran through the night.
So tell me about this system that you guys have prototyped. What's this about?
So we came to talk about three things here at Supercomputing. One, the importance of RDMA in terms of efficiency. We want to use CPU cycles for computation as opposed to using it for moving data around. Obviously that's the goal. And then using microservers, something newer and more power efficient to reduce wattage. And then finally, to provide a file system that works well in this case. And we talk about Hadoop on Lustre here, being able to use the Lustre file system in a more efficient manner to provide the data. So all three of these things basically deal with efficiency of computing and how you can get more bang for the buck, and specifically how you can get more bang for the watt out of it.
So you guys are actually leveraging some chip technology from the telco area, aren't you?
Yeah, that's correct. The T4240 is originally designed for networking primarily, and so it's used in a lot of very high-end switches. It's used in a lot of very high-end firewalls. It can move roughly 120 gigabits per second of I/O per chip, and what we're looking at doing eventually is to get 12 of those into 4U, capable of doing obviously a lot of I/O in that case.
Yeah, so this is a 64-bit device, isn't it?
Yeah, it's 64 bits. It's roughly the power of a dozen A7 ARMs and a half dozen A15 ARM processors. When we look at what the ARMs can do in terms of processing, they can do some of the web serving functions and things like that, but when it comes to doing SSL and other intensive things, they kind of fall on their face pretty much. The T4240, Freescale actually sells a board with a T4240 on it as a SSL accelerator that you plug into your Intel box to make it run faster. So clearly it's got the performance behind it to do some of those tasks much better than what ARM can at this point.
Well, it looked like you had a lot of interest in this. I mean, you think this is a pathway to the future for more energy efficient computing?
It's hard to say where the future will go. If you look at all the lower power processors that are out today, we had to pick this 6 months ago, and you always think that a few months down the road there's going to be something else and you're going to regret having picked one earlier. But from what we can see, the roadmaps of everybody else, there's really nothing that's going to be competitive with this that you can actually buy off the shelf within the next year or so. So you're looking at almost 2015 before some of the other things that have been talked about. Cavium's got a 48 processor chip, but they're only going to be taping that out in about 6 months, and by the time they get to the final version of the silicon, it's going to be quite a ways down the road. Same thing with most of the 64-bit ARM. It's just a ways off in time. Freescale's there now with that kind of performance.